The disadvantages one may come by using the k-mean algorithm is the k number of segments, it should be priorly mentioned. And the second most important thing is we have to initialize the k centroids in the given feature space, right? So there is a one more algorithm called a mean shift algorithm. So this mean shift is nothing but it is a non-parametric iterative algorithm, and we use it as a most powerful for clustering usage. Now, this mean shift algorithm is used in image segmentation as well as in the clustering problems, visual tracking applications, space analysis also. Now, what actually happening in this mean shift algorithm? This mean shift mitigates the issues like once the pixels in the image here are mapped into the feature space, you can see we get a pixel feature distribution, right? So here I can able to find the density of pixels is high here when compared to remaining parts of this image. Now, so this pixel feature distribution, now let me represent it in the other way, that is it appears as a function which has some hills. So if this feature space can be converted into a representation that is having a hills. Each hill is nothing but it is a cluster here. So our main objective is to find out the peak of every hill. Okay, so that means we need to find out the maximum height of a hill or the steepest hill where within its neighborhood. So this is my hill, because if I consider this is one area, this is my steepest hill, and if I consider this that means it is having a highest density of feature vectors here. So this peak is having the highest height of the hill, right? So finally, the pixel here, whatever the pixel is nothing but it is represented in the manner of a feature vector or a feature space vector. And so that means here each and every pixel is assigned to hill. So here if I treat each and every box is nothing but a feature vector, means each and every feature vector is assigned to hill. So this is one feature vector. So it is searching for its hill here. So as it is finding that this is its hill, means the process is again replicated, you can see, and the same process is also shown here. That means here each and every pixel is assigned to each and every hill here. That means all these pixels are climbing to a particular individual hills, and they are finally going to end up at peaks of every hill. So each and every hill is nothing but here they are the clusters. So I do have here some pixels. So this sample pixel in the 2D space here. So ultimately I need to do, or I need to search which pixel belongs to which hill. In other words, I can say the cluster, which pixel is belonging to which cluster. Okay. So I would like to view this pixel location such that as the main value for that pixel. So here I am having a enormous number of pixels, right? So I would like to demonstrate you now how this mean shift algorithm is working. So let me go with the working principle of the mean shift here. So I am having n number of feature vectors or pixels. Okay, so let me assume there is one pixel here. So this pixel location, initially what I am going to call like the blue color, what you are going to see here. This pixel location, initially it is acting as a mean value for that pixel, because I am considering only this pixel. For this pixel, the mean will be itself only, right? That means the current location of the pixel is the mean for that particular pixel. So now what I am going to do here is I am taking a window which is indicated with blue in color, right? So now after taking the window which is of blue color, so let me give the size of this window, circular window of radius W. Then if I consider all the points within this window, circular window. That means all the points that lie within this circular window. I am going to calculate now the new centroid for this window. So ultimately, at the end, the end result may not be the same centroid, right? Because I have considered this pixel, and for this pixel, the mean will be blue color. Okay, and after that one, I have wrapped this pixel with some window, circular window of radius W, and in the circular window, I am having enormous number of pixels. So that means now what the job I am doing here is I am again finding out the mean for all these pixels. And now it is giving me a result that the mean is not same as it was in the previous. The mean got shifted. So the mean is shifted here. You can see light brown dot here. So that means it is a mean shift vector. So the mean is getting shifted by some vector, that is called a mean shift vector. And so this is the vector by which our difference between a new mean to a old mean, that mean shift vector is giving us. So this is a mean shift theorem. Okay, that means this process of finding out the optimum centroid for a circular window is repeated continuously, and last we are finally ending up by climbing the highest hill in the circular window. That means because as the previously my centroid is here, now the centroid is shifted here. So that means this centroid is shifted here means the new circular window is also shifted, right? So which is indicated with brown in color, light brown in color. So after that one also, after finding out the mean of all the pixels in this light brown circular window also, I may not end up with the same centroid. The centroid is again shifting towards the right side. You can see. So finally, my centroid is ended here with green in color, and if the centroid is shifting means definitely the circle also will be shifting. So that means from here to here first shift happened, from here to here second shift happened. That means can I say here I am climbing to the steepest hill. This process is repeated continuously where I will be ending up climbing the steepest hill in this circular window distribution of pixels, right? So that means our job is to recompute the mean until and unless we achieve the highest peak, or we achieve the peak peak point here of the hill. So that means here for this pixel, so for this pixel or for this pixel, the mode or peak of this is the hill. So for this pixel, the peak will be here, and for this pixel also the peak will be here, and for this pixel also the peak will be here. As how we have done like wrapping this pixel with a circular window and shifting its mean, and after that it is reaching here. In the similar manner, we are doing the same job for this pixel and for this pixel. Finally, these three pixels are going to end up in climbing this hill. This hill is nothing but it is a mountain or it is a hill. That means these all the pixels comes into a one cluster group. So this what happens in the mean shift algorithm. Okay. So since this hill is shared by many other points, right? So where we are going to get other points also. That means this as this point or as this mean or as this mode or as this hill is shared by many number of points. So many number of points are also climbing the same hill here and ending up with this hill, right? So these all the features are, or I can say these all the pixels are converging here to same mode. That means these all the things or all the feature vectors belongs to same cluster here. This is the idea of the mean shift algorithm. So in simply I would like to explain like I have here n pixel feature spaces or n pixel feature vectors. So according to this main shift, we have to in that like I am having fi, like I am having here any number of pixels here, that means any number of feature vectors. So for each and every feature vector or each and every pixel, the pixel initially the mean for that pixel is itself only. The mean for this pixel, if you see here, the mean for this pixel is itself only. So after that one, what I am doing, I am placing the window of size of radius w for this pixel, computing the centroid or again within this window. So I will be getting the new centroid and that centroid will be shifted. So for how long this main shift vector is taking place means, so the first centroid is here, the second centroid is here, third centroid is here. After that one, there is no more shift. Why? Because I have stopped shifting the mean here, as the mean shift vector is less than the threshold. That is why I have considered this as my maximum mode or highest hill, steepest hill here for this group of pixels. So that means for all the pixels blue, violet and red, this is the hill. That means all this comes under a one category. So this is the concept for your mean shift algorithm. So the same thing I have given. The difference between the k-means and the mean shift is latter one does not need to specify the number of clusters. So in the explanation, I didn't mention you that so and so number of clusters are present, right? As how I have mentioned for the mean k-means, I didn't mention the number of clusters because the number of clusters will be determined by the algorithm of mean shift itself only. So for each data point, mean shift defines a window around it, right, and computes the mean of the data point. So then it shifts the center of the window to the mean and repeats the algorithm till it converges, right? So this mean shift algorithm assigns the data points to the clusters iteratively by shifting points towards the highest density of data points. In fact, cluster centroid. That means it is the steepest hill or mode. So there is one kernel density estimation here for estimating the density function of a random variable in a non-parametric way. It is usually called Tarzan window technique because I have considered one window, right, in the explanation part. So this kernel density estimator for a given set of dimensional points is given by this formula, that is f of x equal to 1 by n into h power the sigma I equal to 1 to n k of x minus xi by h. So h indicates it is the radius of the circle, k of x is nothing but kernel, and we do have n number of data points. So I equal to 1 to n. That means x of xi is nothing but it is a new centroid, it is the whole centroid, it is mean shift, right? So m of x is nothing but it is a mean shift vector. The estimate of the density gradient is defined as the gradient of the kernel density estimate. So this is my kernel density estimate, right, for which I am going to find the gradient del of f of x. So this del of f of x is nothing but I am doing first derivative. Gradient is nothing but first derivative, that is del k of x minus xi by h. Now what I am doing, I am just replacing this k dash, that is first derivative, with g of x. So just replacing this one with g of x. Finally I am going to obtain my mean shift vector m of x as given by, this is the ultimate result. So this is about mean shift algorithm, and let me have a look on the results. So this is my original data feature space that I have been provided with. If I apply the k-means algorithm, the resultant clusters will be in this manner, and if I apply the mean shift algorithm for this original data set, I am going to lead this as my result. So I can feel that the results of clusters after applying the k-means and mean shift a mean shift is giving me a bit more clear results. So this is about the mean shift algorithm. Thank you. Have a nice day.